placed a 6-inch shell upside down in a glass fibre tube in the centre of this rack of 24 6-inch tubes. We used cardboard, HDPE and glass fibre tubes for this experiment. The second detonation you can hear is from a shell that had landed 80 metres away from the rack. We discovered that the cardboard tube had been sheared off during the initial event, and the subsequent heat had ignited the shell's lifting charge, which then launched from a 30 centimetre tube. At the time, somewhat unnerving for us, as it landed behind where we were filming from. One of the most important things we learned from this test: it is very important that the racking system prevents sympathetic detonations of other shells. Especially with digital firing systems, it is possible that there can be unfired shells surrounding the shell that has detonated in the tube. To eliminate sympathetic detonations happening with our racking systems, we made the bottom ladder stronger than the top ladder and used HDPE tubes. These 3 glass fibre tubes all sheared off and were part of the sympathetic detonation. This HDPE tube was forced through the lower separating rung of the ladder but still stayed intact, and the shell inside this tube was not affected. This shows even with 100 mm of space between the tubes in the ladder and 200 mm of space between the individual ladders, if a sympathetic event occurs, the rack could fail. This shows the force involved during a sympathetic detonation. The outside rack has been forced out from the centre of the rack. This HDPE tube had been forced through the rung of the lower ladder, but the tube remained undamaged and the shell inside this tube remained undamaged as well. These cardboard and glass fibre tubes did not cope so well. Glass fibre tubes can be used, but should be separated by HDPE tubes to avoid any sympathetic detonations within the rack. We also tested the HDPE tubes by firing a shell upside down in the tube and found that although it did burst the side of the tube, it was not completely destroyed like the glass fibre tube. We observed that less energy was directed sidewards in the HDPE tubes and therefore helped to prevent sympathetic detonations of the neighbouring tubes.